So, hello, I am Nour El SABBAGH. I am a postdoc in CEISAM of Nantes. My research concerns automation, having flow chemistry, and also using high-field NMR. And there at CEISAM, we want to build autonomous platform that do flow chemistry and that uses high-field NMR for detection, for the analysis. And we want this whole platform to do optimization of reactions. So yeah, we are building this, and actually it's already built, and we are happy to do application with it. So it's automated using MATLAB coding. It's a MATLAB code that controls equipment, different equipment like pumps, reactors, heating plates, etc. And we have automated control of the high-field spectrometer. The optimization is done with using algorithms. So for now, it's not artificial intelligence, but it might be one of the future advances in this project. In CEISAM, we have the idea of building autonomous platform that doesn't require any hand involvement of the users or the chemists. With this platform, we want to do optimization of chemical reactions because, let's say, traditionally, if you want to optimize chemical reactions, it relies on a lot of resources, a lot of waste, maybe time and also resources, and it relies also on error. So having a platform that do flow chemistry, because it's going to be different from traditional chemistry where the chemists bring different compounds, mix them together, and then heat them, sample them, do the analysis. So in this process, there is a lot of error dependent on the chemist also. When we do flow chemistry, it's actually flowing reagents using pumps, flowing them into reactors when they start reacting. And then after this, we could have outcome of a set of, let's say, conditions. And what we are doing is actually automating this flow platform. And this outcome is directly given to the high-field spectrometer, where we could have analysis. To do this, actually, we have created also a communication and control of the high-field spectrometer. So it's really automated. So we have included that. So now we have a fully automated platform that does the whole process from the beginning of the mixing of the reagents, setting up conditions, letting reagents react until the analysis and the outcome and the processing of them. And at the end, we want to optimize reactions. So this idea, we have built it as a loop using algorithms. And the process is, we have the reagents that goes into the system, and we have the reactions going on. It begins, it goes into the high-field spectrometer, and there is the analysis, and the outcome of this analysis, it is actually fed to the algorithm, and the algorithm is gonna see if it's a good experiment or not. So here the user in advance, the user has to provide our system an objective. Let's say the user wants to increase a yield of the reaction, or maybe the throughput of the reaction, or even minimizing the cost of a reaction. We give the system an equation that is defining this objective, and we tell it that we want to increase it or decrease it. And then the algorithm is very smart. It can comprehend a bit the variable space we have. Maybe it's gonna try to suggest new conditions to try and see what kinds of results we have. And this algorithm is going to move away from experiment conditions that are not working well and getting closer to the ones that do. So it's a very smart platform. With just a start button, we can enter this whole autonomous workflow, and it only terminates when the objective is reached or if, for example, the user sets at the beginning, like I have a budget of 20 experiments and I want to see where I can go with it, how well I can optimize this reaction. So either the system will stop if the objective is reached or the maximal experiment is reached also. So it's a closed loop, but it's a very smart one, and it can give us valuable information. With this platform, it has already been developed a couple of years ago. It's not new this year. In CEISAM, it has already been used with benchtop NMR and with HPLC. So using high-field NMR is going to bring lots of more information, maybe a study structure that cannot be done with benchtop NMR, and it's going to bring more information than HPLC. So it's kind of, let's say, a complementary analysis we are using. Bruker already have the flow unit available. So, and in CEISAM, in our platform, NMR platform, we have a fume hood that is right next to our 500 megahertz. So it helps, and it's new to the field, so yeah, why not? What I'm doing in CEISAM is a lot of fun for me. It combines my two passions, coding and NMR. So I would like to stay in this range of NMR, and of course I would like to stay in research, because being a part of this movement, let's say, it's very important. And as a very young researcher, I'm not even a researcher, I'm very young. I just got graduated, and yeah, maybe something related to research, automation, NMR is gonna be great for me. And I hope I would find a job in this area. And I know it's a very important movement in the field, and it's going towards even more beautiful applications. So there will be opportunity in this, but maybe I should keep an eye on what's going on in the world, not even just in France.